Thanks for coming to my session at 4 p.m. This is Freedom Through Structure, how Whoop scales analyst autonomy with DBT. If this is not the right session, you still have time to go find the right one. But a little bit about myself. I'm your speaker, William. I'm a senior analytics engineer here at Whoop. If you don't know what Whoop is, we are the human performance company. What that means is the last 15 years, we've been building one of the best, the best fitness wearable on the market. We're the only one with 24/7 health biometric data collection with artificial intelligence coaching. We have some of the highest engagement within the health and fitness industry. If you are interested in trying out some of the most advanced tech out there, we do offer a free 1-month trial. Just to whet your appetite, here's some statistics that you can keep an eye out. If you get our application, I'm in particular really interested in seeing what my stress score is going to be like after this. We're trusted by some of the world's top performers in addition to that. Now, before I go on with my presentation, I'm going to give a little bit of context on where I'm at within Whoop, where I sit within our broader analytics team. I'm part of a department called Business Analytics, led by our great senior director, Matt Luisi, right over there. Clap for him for showing up. Within that department, we have 4 teams: marketing analytics, product analytics, growth analytics, and the team that I'm in, analytics platform. We consist of right now around 3 different individuals. I'd say we're all really competent analytics engineers. We really support 20 different data analysts and scientists. It's growing every single week within our partner teams. We're really focused on maintaining the tooling and enablement so that these partner teams can use data for things like financial reporting, A/B testing product features, things of that sort. One of the tools that we minister, one that's really close to my heart, is our DBT cloud instance. We have about 15 different DBT projects. We're on a data mesh kind of system. Our largest DBT project has more than 1,100 plus different models, and it's used to power downstream assets used by more than 1,000 different users. I joined Whoop about 2 years ago. When I joined Whoop, we had a relatively immature DBT practice. What that meant was that we had pretty frequent failures, meaning throughout the week, models would be breaking every other day. That was a lot of constant firefighting, poor data reliability, and general stakeholder distrust. In addition to that, our DBT project had inconsistent modeling and DAGs. That meant that there was governance risk, there wasn't really standards, high maintenance costs. When I joined Whoop, we were always heavily leaning into the idea that analysts should have the autonomy to maintain the data models that they are building, but the same analysts would also have uneven technical proficiency when it comes to things like Git, DBT, and SQL, leading to slower dev cycles and more bugs. In addition to that, I would say our general developer experience was rather immature. We didn't have a lot of guardrails, a lot of low confidence with changes. So that's sort of the backdrop when I joined Whoop. One of the first projects I was tasked with doing was basically refactoring our entire DBT project and the processes around it with the focus on stability, scalability, and maintainability. With the very specific lens that this DBT project, analysts are going to have the autonomy to go change the models as needed to fit what their business stakeholders need. When we think about what a successful refactor would look like, the success criteria for me was a consistent DBT project design, faster onboarding of the data analysts, confident contributions when the analysts send code into this DBT project, pipelines that are reliable, data assets that are monitored and therefore trustworthy, and operational scalability. We need a process that doesn't require a lot of analytical engineering support. So for the rest of the slides, I'm going to be going and using that success criteria and talk about what we did in order to address that. The first one is going to be a consistent DBT project design. This one is just really about establishing your DBT architecture early. Now, what this really means is you need to talk with the leadership on your team and instill with them a playbook of what your DBT project is going to look like. What I've identified here is 6 pillars that I think you should be thinking about when establishing that playbook. But I want to emphasize that the goal here isn't to pontificate on what a perfect DBT project is, or to go into the intricacies of a star schema versus a one big table, or whether you're leading commas or trailing commas or whatnot. It's about consistency. This is going to be the playbook that you pass along to your analysts and what they're going to be judged upon as they send code into your code base. So just to give context into how Whoop has set it up, mono versus multi-repo. We're on a data mesh. When I joined Whoop, we were already splitting our DBT projects by business domain and application usage. So a data mesh made a lot of sense there. Folder structure, it makes a lot of logical sense for us to mimic database objects within our data warehouse of choice, Snowflake, within the dbt project. What that means is a one-to-one folder between database, schemas, tables, and views. From a DAG layering perspective, let me go with a simple 3-layer. We call it stage intermediate presentation. That ties neatly into naming patterns. If you're building an intermediate model, you should be landing it into your intermediate database and including a prefix like int underscore to make it very clear. Data modeling perspective, although I have a star schema here, we're actually one big table shop. That really means building out very wide tables that are optimized for query usage. We thought it made a lot of sense when it comes from enabling analysts to be working with the dbt, but it also was a very nice way to work with the broader tech stack we've built around our data warehouse. From a deployment and testing perspective, we aligned that we're going to do a weekly release cycle where we are going to be using data tests within dbt to identify any P0 errors, but we also have onboarded third-party observability tools and performance tools to give us a better sense of our health of our dbt project. In this case, Monte Carlo for data observability and data governance, Select Dev for performance. Now, the first thing we're going to be talking about is getting your data analysts onboarded onto your dbt practice. Now, as I mentioned before, Alex platform, we're a team of 3. When I started, it was a team of 1. That makes us a perfect candidate to leaning into the idea about using dbt platform tools. What I've highlighted here is some of the tools within the dbt cloud platform that I found to be incredibly helpful when we're thinking about getting WOOP analysts into the dbt ecosystem. First is catalogs and insights. We found that this is the go-to catalog when working within dbt to understand what models exist. It also provides an insight feature, which allows you to see the data within the catalog itself without having to context switch into a BI tool or other things. dbt Studio, that's the web-based cloud IDE. This has been incredibly helpful for analysts because they don't need to install dbt locally onto a computer. They can just log in, use the web browser, and it allows me to also offload things like version management. I don't need to worry about a dbt user using dbt 1.0. Nor do I need to worry about credentials, because credentials are stored within the web browser itself. They don't have to accidentally submit a GitHub pat token into our GitHub repository, and I need to go and rotate those personal access tokens in a secure manner. Within dbt Studio, you also have dbt Copilot, which I've been found to be an effective way to get your feet wet in this idea of using AI to assist with code generation. We also heavily leverage the state file. We found that allows analysts who just really need to focus on building the models that they've actually modified without spinning wheels, running everything upstream, or doing cloning data within Snowflake or things of that sort. dbt Mesh has been incredibly helpful in model reuse in our data mesh ecosystem, and also connecting the dots between how one model is used in one project and how that leads to a model in another. dbt also has a great control plane when it comes to orchestration. It's very easy for me to just show the analysts, here are all the jobs we're running, this is when they ran, this is when they finished, this is when it failed, and this is why it failed. Now, I do want to say, though, it is still important to provide tooling to match different levels of complexity. We do offer solutions to the analysts beyond just what dbt provides. For example, from a version control perspective, if you're an analyst who haven't used GitHub before, I don't throw you into the deep end working out of the Git CLI. I start you in easy mode with the GitHub website. Create a branch, send a commit, do a pull request, get familiar with the peer review process before submitting it into the actual code base itself. Once you're comfortable with that, you've built in a few reps, move on to dbt Studio with its on-Rails guided experience. And when that's no longer sufficient, that's when I begin to introduce things like GitHub Desktop or the Git CLI. From a dbt development perspective, dbt Studio is the entryway that I have analysts working with dbt out of. But it is a web-based cloud IDE. There are limitations to that. If you've outgrown the web-based cloud IDE, that's when I introduce dbt CLI. You still get all the greatness about a managed dbt platform, but now you can work with your local IDE of choice, something like VS Code. And if you really want to, you can even go and just install dbt locally onto your computer and go into even more advanced extensions. Maybe you want to try dbt Power User. Maybe you want to be using Cursor. You have the freedom to do that. From an orchestration perspective, if you're getting your hands wet with dbt, just start with dbt build, run it manually. But if you need to begin to get it running out of batch, that's when I introduce you to dbt orchestrator, the idea of cron jobs, things of that sort. If you're beginning to enter even more advanced workflows, like an event-driven workflow, that's when we use a third-party orchestrator. The one we use is Prefect in tandem with the dbt API. From a monitoring perspective, dbt Cloud has a good general observability way, dbt catalog, insights, model run timing. But if you need to get even deeper into that, we use select.dev to give you insights about performance runtimes, Monte Carlo for general data governance and observability on that front. And if needed, you can still query with the right permissions and roles and access the query logs within our data warehouse and just build out custom dashboards to understand the queries that are being run. From an AI assistant front, I think all analysts start with ChatGPT, talk with it, throw something in, get the SQL query, copy and paste it out, drop it there. But a quick fast follow from that is to use something like dbt Copilot, get that command B, type in a prompt, see your SQL query being edited on the fly. The logical extension after that is to then use something like Cursor. I want to give a pragmatic lens into where I found AI to be as helpful to the analysts at Whoop. First one is a conversational understanding of Whoop's dbt architecture. If we go back to my first success criteria, which is a consistent dbt project design and the importance of documenting it down, the reason why that's important is one, you've put your decision points there, but you can feed that as context into ChatGPT and create a chatbot that analysts on their own time can basically talk and converse with. It can act as a tier 1 way for analysts to understand what you're trying to prescribe to them without them continuously coming by and doing a swing by and saying, hey, what's an intermediate model? From a SQL support perspective, I found that it's great at drafting your initial SQL, but I also found a lot of success in just asking, what did another analyst try to do when writing that SQL? And maybe even add comments into it to explain each and every single individual step. Documentation boost, AI is really good at doing that. You can get 80% of the way there when it comes to table, column, and semantic descriptions. It's not going to be perfect, but the mere fact that you just have to deal with the last 20%, get it wordsmith to actually match what you're trying to do is a big productivity gain there. It's also good at very simple repetitive tasks. If I'm doing a filter within all of our staging models, maybe swapping a source where a control F and control R just isn't the easiest way to do it, AI has been able to handle that pretty well too. Everything I've talked about so far has been about tooling and how tooling can be helpful, but another side of it is also going to be about upskilling. So in this area, it's about identifying the gaps that your analysts have. The Analytics platform team reviews every single PR that an analyst sends into the GitHub repository. And what that means is, as an analytics engineer, I have a front-hand view of the enablement and friction points that analysts are facing. I take note of that within each and every single one of those PRs. In addition to that, we also have blameless postmortems. If our dbt production job fails, we need to get to the root cause as to why it failed, and is there any learning opportunities from that. When you have those set of enablement gaps that you've identified through that, we can then begin looking into recurring enablement sessions. Here at Whoop, we have something we call a dbt guild. This is a once-a-month hour session where we basically go over key topics within dbt, and I would argue the overall analytics engineering space. Usually the key topics are heavily informed by the friction points I've been seeing in the prior months' PRs that analysts are sending in. In addition to that, we also have weekly office hours. If you have something, you just need asynchronous support, we have an hour of time dedicated just for that. So all of that has been about enablement, getting analysts onboarded, working within dbt if they've never used dbt before. The next thing we want to talk about is, all right, how are they going to be confident about the contributions they're going to be sending in, and how do you make sure that your pipelines are reliable? Here at Whoop, we rely on indirect promotion. Now, if you're not familiar with the various ways to deploy your code out from dbt to your data warehouse of choice, check out that URL straight from the dbt blog post. I think they describe this better than I may be able to in this presentation, but I'll give it a try. Indirect promotion in its most purest sense implies that you're going to have two long-living branches. One is going to be your main branch. This is your production branch. This is what powers your production warehouse. You're going to have another long-living branch that is just going to be a little bit ahead of your main branch, and this is going to be called your middle branch. We call it the QA branch. Other companies may call it the UAT branch. This is being used to power another data warehouse that for the most part is pretty similar to your production database. In addition to that, you're going to have feature branches. These are going to be the small atomic PRs that your analysts are sending in. These are not long-lived. These are going to be short-lived. These are the ones that the analysts are going to be submitting to the analytics engineer to review to get into the middle branch and eventually into production. So I'm going to drill in a little bit into our process in getting feature branches into the middle branch. We require 2 business reviewers at the minimum. The first one's going to be a business domain reviewer. This is someone who's going to be a business analyst, maybe your manager. The goal here is we want another data analyst who can comment on the logic that you're trying to introduce in your feature branch itself. But this also introduces redundancy. If the main author or maintainer of a model, for whatever reason, needs to be out of the office, we have someone else that we can go and talk with. The second person is going to be the analytics engineer. We're going to be reviewing the PR for the more overall architectural fit. How does it fit into our DBT project from a 500-foot pole viewpoint? Are we potentially seeing a PR that's introducing a model that's very redundant to another team's model? Are we seeing things where PI masking is not being applied? Descriptions don't really make sense. This is where the analytics engineer comes in. At this phase, we do have CI checks. But this is a feature branch. We are expecting you're going to be sending a lot of commits in to get it working. So the emphasis here is going to be very lightweight CI checks. Here we leverage heavily the DBT empty flag. If you don't know what that does, all it does is add a limit 0 to your table materializations. It really makes it very fast for you to just make sure the SQL executes itself. And we also leverage state modified. This basically makes it so that the CI check is only running the specific models that analysts are actually modifying at that point in time. This is also a great way to put in your documentation checks. If you're adding a column, are you documenting that column? Are there typos in your semantic metadata? Those are quick checks that can be done at this phase. Now, we are going to be talking about getting this into production. We call this the weekly release. Why? Because it happens once a week. We found that this is one way to balance velocity and reliability. The way that this works is before we release code out to production, we actually want to mimic what the deployment process is going to look like. And furthermore, in addition to that, at least one daily batch job run within the QA database. So to mimic the deployment process, what we leverage is dbt clone. Basically what this does is copy the data within your production data warehouse, put it into your QA data warehouse. This is a great way to basically sync up your incremental models and your snapshots. Then we're going to go run our deployment job. Usually this is just going to be your run-of-the-mill dbt build, state modified, and everything downstream. But on occasion, we might be touching something that requires a full refresh. So this gives you the opportunity to inject a fine-grained command to see if that's actually going to work if you're going to try to deploy something out to production itself. Now, if there's a successful deployment the following day, we are then going to run our QA database at the exact same time as our production database. The reason for that is that this is going to give you a one-to-one comparison, not only in the QA database and production database assets, but also regarding the DBT project runtimes. At this point, you've been seeing me use the dbt build command this whole time, so automated tests are being run at each one of these steps. But because you've also created a QA database that should match your production database, this gives analysts a very easy way to apply their analyst touch and see if the regressions that they've introduced into that QA database actually match what they're trying to do. Only after all the analysts have said that, hey, the changes I've introduced is exactly what I wanted in the QA database, will we then release this out into production. If they need any last minute changes, go ahead, send it in. We can run the QA database in a more fine-grained manner, but we're not sending this out into production until every single analyst who's contributed to that week's release has given me the thumbs up. Because this is done once a week, we also can time a weekly summary out to the company consistently. Every Friday, 10 a.m. at the dot, we send our release notes to the company describing the data model changes, what tables were added, what tables were removed, what columns were added. And in addition to that, any key metrics executives might need to expect to see because of that week's release. I want to say, I do want to go over some pros and cons. On the con side of this, we are putting ourselves on a weekly basis. So if you do need even higher velocity, this might be more overhead there. And there's also a steeper Git branching learning curve. You do need to work on making sure you have 2 long living branches that are pretty much in alignment. There's a little bit of overhead that comes with that. That said, on the pro side, this kind of weekly ritual forces thoughtful prioritization. An analyst really needs to ask, if I'm making a change, should I rush it and send it this week? Or is it better if I put a little bit more thought and effort and try to send it in the week after? Furthermore, having a full QA deployment and a full QA batch job also makes it so that from the analytics platform side, I'm pretty dang confident we're going to have a successful weekly release there. The great side effect of this is you'll also get a safe secondary database that allows for safe experimentation. If you want to play around with a new feature, you want to play with Python models, or you have some gnarly Jinja macro that you want to start playing around with, the QE database is there for you to do that. The worst thing can happen, breaks, whatever. Overall, when you have a weekly release cycle, you're going to naturally see this ritual start forming where you holistically can see how your project more consistently evolves from a data modeling perspective, but also begin to reflect on the enablement gaps. The ideal sense is, as weeks progress, you're going to see less and less of those friction points being raised within the pull requests that analysts are sending in. I want to call out that this process of indirect promotion is still flexible enough where if you do need to send something to production, you can. You just need to rationalize with the analytics platform about why you want to bypass all these guardrails. The next section is trustworthy data assets. What is the monitoring we're doing to make it feel that the assets we're producing is trustworthy? From my perspective, there are sort of two pillars we're looking at here. The first one is going to be data testing. Is the data assets being produced complying with what we are expecting? From here, we use DBT tests when we want a P0. If the pipeline needs to break and downstream assets should not be refreshing, this is where DBT tests are used. If the main goal here is for analysts to just get visibility into things that are happening, it's not super mission critical for the pipeline to pause, this is when you use DBT warning and our third-party tools like Monte Carlo. At this phase, we also use the PR review to enforce this idea of strategic testing. We do ask that analysts that when they are writing their pull reviews, they do need to think about data testing. If they're not going to add a data test, they need to explain to me as your DBT project SAR, why are you not adding a test? Maybe you already have test coverage, maybe you don't think it's important because it's experimental, you need to explain to me why not. If you are adding a test, you also need to explain to me what value is this test going to bring? Why do you think this is going to make the asset a higher quality asset than it is if you did a different kind of test? From a performance side, I sort of alluded to this, because we're doing weekly runs that are one-to-one, you get a preemptive lens of how much longer or shorter your new week's release is going to be. This gives you a chance to actually look at the model run timing to see if there are any bottleneck models. I would highly recommend that if you're on Snowflake, that you look into a myriad of different DBT packages you can get that will basically inject query comments into the SQL queries that DBT is running. You can use these comments in addition to the metadata within the warehouse to make rationalized decisions about whether you need to use a bigger warehouse, you need to add more clusters, or even something as simple as a cost rationalization exercise. This SQL query that you're going to introduce is going to cost, I don't know, $100,000 in a year. Is it really worth it to have it running every single day? With all of that, I think we can go back to revisiting our success criteria and at least go over what we've seen happen at Whoop. When we think about consistent DBT project design, our DBT project very consistently follows the established project architecture that is there. Oftentimes now, I'm not the one who's actually needing to act as the SAR and making sure that you're following these guidelines. I often see that analysts are actually self-policing themselves, saying, hey, maybe this is an intermediate model, maybe this needs a different kind of test, things of that sort. Faster onboarding, we're based in Boston. We have a co-op program, which basically means we get college students who join Whoop for 6 months. I've consistently seen these college students get onboarded within DBT within the exact day. So incredibly fast onboarding here. Contributions are done with a lot of great confidence. There's a lot of guardrails in place. Analysts know that's very difficult to send in code that breaks production. And furthermore, because there is a QA database, they can physically see what they're doing before it ever gets released out to the wild. On that end, pipelines are pretty reliable. I'm going to say I don't see my DBT pipelines fail ever because of what analysts introduced. If they do fail, it's because of novel issues due to the source data. Assets are trustworthy. You're monitoring them. You have the receipts that you're looking for these particular attributes to make sure that they are accurate. And then the final one that I didn't have a slide to talk about is operational scalability. If you think that everything I've said here is a lot of overhead, I can basically say that one part-time analytics engineer, meaning this is not my full-time job here, can basically support this process for our team of 20 plus different analysts and data scientists, which is a pretty low commit if we think about the overall grand scheme of things. That does lead ourselves to next steps. I alluded to this, our dbt pipelines still do fail, but when they do fail, they tend to be due to issues within the source data itself. We're trying to find ways if there's ability for us to be notified when the source data breaks in a manner that's going to impact our dbt project, but also if there are graceful ways to actually correct the dbt project before the next morning's run. We want to be looking at ways to make the manual QA of the QA database and production database easier. Are there ways where you can just get a metric readout where on a high level you can see how metrics changes based off the commit that an analyst makes? Are there additional CI checks we could add in? Maybe data diffing? Overall, if all of these seem very familiar, we're keeping a very close eye around the features around Fusion because of the developer experience add-ons they're trying to work on. The things I'm particularly interested in, Fusion, the VS Code extension, I think that's going to have a lot of benefit when we think about onboarding analysts to dbt itself. Remote dbt MCP servers, another way to converse with your dbt project in natural language. And also if there's other more monitoring tools that we can get into our dbt platform. One that piques my eyes in particular is the native cost management monitoring that they're building out. And with that, I'll open it up for any questions that people may have. Assuming there's time. I might have gone a bit over.
In the table that shows the simple to complexity for monitoring, I did see that for the complex, it had custom dashboards. I was curious, what metrics was those custom dashboards measuring?
Yeah, so I think the one that we use here is we use Sigma as our BI tool. So if there's things that select.dev isn't actually directly monitoring, you can always go into the Snowflake query logs and begin to look at those in more detail. In this particular case, we actually have Matt who has his own little dashboard in that case when he needs it. For me, myself, I usually use that if there's just you want a holistic point of view that select.dev isn't the greatest for because it's more fine-grained.
Okay, so the dashboards measure against Monte Carlo, the third-party tools?
Yeah, exactly, yeah.
Okay.
So it's another way to basically get monitoring out there.
Perfect. Another question, if that's okay, is for weekly releases, are those all manually, or do you have something automated that generates those weekly release notes?
The weekly release notes, I basically copy and paste what analysts are writing in their PR template. I throw them into a large language model against a general template. I still need to go back and wordsmith it a little bit because it's not going to be 100% perfect or there, but it gets me 80% of the way there.
Thank you. I have a question.
Yeah, for sure.
My name is Lorenz Mettering. I'm a huge Whoop fan. I have my Whoop device here. I have two questions. What's your recovery today?
Not bad, actually. It's a 50.
Oh.
Not bad.
Mine's
1.
Mine's 67%. Not bragging, but my second question is, can you give a specific example where this framework has really helped speed up the process for a specific feature? Like you have advanced labs, which is really cool. Or if you're able to speak to that, how
Yeah,
that's
I absolutely can, actually. Awesome. So Advanced Lab was released, or not Advanced Lab, I'm going to talk about actually our Whoop 5.0 release, which happened a few months back. When we released out a new product, we needed to actually completely set up an architecture within dbt where we're getting reports in near 15 minutes. This entire cycle and process, all this enablement that we've done with the analysts to get them onboarded with dbt, along with, I mentioned here, the idea of having prefect and dbt API, basically led it so that for that framework to be set up, I actually didn't even do much. I just let the analysts cook, and we were able to get dashboards updating 15 minutes or so. Something that just would not have been possible prior to all this enablement and architectural effort.
You mentioned on your release, you're releasing QA to over here to main. What are you doing when one analyst isn't able to fix a problem in QA?
Revert it.
You're reverting.
Yeah, it goes to it's not ready, push it to next week. If you absolutely need it out, we can do an expedited release where we will send it out the Monday after. It'll still go through the QA database. That alludes to the idea of flexibility where you can push something to main if needed. But, yeah. Once a month or so where they can't fix it. I would say it's more frequent that I'll find an executive asking for something immediately. And in that case, I'm definitely open to doing that. I just need a good reason to do that.
Question here. I think at the beginning you said you use a mesh
Yes.
You use multiple projects.
Yes.
How do you manage the release across those multiple projects? Could you
Yeah,
speak
that's
to
a
that?
great question. That goes to our more broader DBT mesh architecture. So the way we set it up is we have one core foundational monorepo. This is the one where a lot of the weekly release stuff is going in. The second aspect of that is all the surrounding DBT projects that we set up, we've made the implicit agreement that these don't need as much governance as this core monorepo itself. We are basically saying that, hey, we're building out these micro DBT projects with the very intent that these are meant to be fast velocity, but lower governance. With that said, weekly release, you know the data model changes. Usually it's a pretty quick, fast follow to adjust those if needed.
One question. You have both prod and UAT. We found that like DBT jobs themselves are like a big driver of like cluster usage. So I guess my question is like, effectively, if you're doubling the number of DBT jobs you run, how much is that increasing your bill in terms of
It's actually a cost
compute?
saving because you have to consider the other possibility, which is continual deployment. If you're seeing analysts sending in like, let's say, I think on average we have like 15 different commits. If you need to continuously deploy that out and everything downstream, that adds up versus just one batch once a week.
So like if you have many different pipelines running on different cadences, does your UAT pipeline, like what is the actual schedule that you're using for UAT? Is it just the one time?
Just once a week.
Just
It's
once a
two
week.
jobs. It is deployment Thursday morning at the same time as prod.
Okay.
And
Cool.
you compete that with the alternative, which is every commit you need to deploy that out and everything downstream.
And does
Or
that-
you could just YOLO dev it and just let the daily job
And
run,
that
but
doesn't
that's
hurt
not
like prod
recommended.
performance? It doesn't hurt prod
Nope,
performance?
we separate warehouses.
Cool.
I think that's a, let's see. Do we have time for one more? All right, we'll do one more and then that's it.
Okay, for sure.
Thanks. You mentioned in order to go from UAT to or QA to prod, you require that all the analysts
Yep.
confirm 100% of their regression tests.
Yep.
What form are those regression tests taking? What form do they take?
Yeah, so one of them could just be like, hey, you have a metric with a custom SQL query. You go run it. Does it look like what you're trying to do from the metric point of view? You can also do it from a dashboard lens. Like you have a dashboard that points to the QA database. You have a dashboard that points to the prod database. You put them side to side and do a visual inspection. So there's like a visual regression that comes from there. There's a lot of freedom with the analyst to basically say like, how did you QA it? Why do you think this is right? That sort of goes to the idea of analyst autonomy. But those are just two examples in which they've done that.
Okay. So a lot of manual. I mean, it could be visual, it could be running a SQL query, it could be
Yeah,
another
at the
thing.
current moment. We do have like data diffing that can happen, but like data diffing is really just like row counts, schema changes. I think one of the things we do want to look into is like actual metric changes. All right. Well, thank you for coming, y'all.